Alright, today's video is about one of the two special triangles that we're going to talk about in class. So the first is called a 45, 45, 90, and where it comes from is a square that is cut in half diagonally. And so we know that a square, all the sides are the same. So for example, if the side length was 1, this side length would be 1. But since we're dealing with a triangle, we're going to get rid of this piece. And we know that a square has 4 right angles. So we have a right angle, which makes these angles here 45 degrees. Okay, so that's how the triangle is created. And now we're going to talk about what is the length of this particular side of that diagonal. So we've learned in the past we can use Pythagorean theorem. So these two sides squared, if we add them up, so if we have 1 squared plus 1 squared, that's going to equal to our diagonal squared, which we'll call x. And so 1 squared is 1 plus 1 squared is equal to x squared. So when we go through the steps, we find out that x is equal to the square root of 2. So up here, we're now going to change this to the square root of 2. So this becomes our model, our model triangle that we're going to base everything on. Okay, so what happens is this. If we take this particular triangle and we want to make it 5 times bigger, for example, that means that these sides are now going to become 5, and this would become 5 times the square root of 2. Hopefully that makes sense to you guys. So we just make it bigger. So this is technically 1 times the square root of 2, right? And so what ends up happening is we have now 2 parts to the triangle. This is called the hypotenuse, and these are called the legs. Okay, so the hypotenuse is going to equal to the length of the leg times the square root of 2. Okay, so if the leg is 8, the hypotenuse will be 8 times the square root of 2, if that makes sense. So if the leg is 8, it's 8 times the square root of 2, and we leave the answer like this. We don't want decimals in this particular lessons. We want the answer written just like this. Okay, so hopefully that makes sense where that shortcut comes from that we're going to use in class. Now, what happens if we're given the hypotenuse in the form of, say, 16 times the square root of 2? Right? How do we find the legs now if we don't know what it is? Well, we know from the shortcut that this would be the leg times the square root of 2. So in this example, the legs would be 16. So this particular formula kind of goes both ways depending on what is given to you. Okay? All right, so let's get to another example here that's a little bit trickier. Right? And so in this example is something like this. What if the leg was 8? Okay. Actually, let's do this. What if the leg was 2? Okay. Well, if the leg was 2, these two sides would be x. They would both be the same. So if we use Pythagorean theorem, we would get something like this. And so how many x squareds do we have? We have 2, and that is equal to 4. Okay. And so then we would divide by 2. I know this algebra right here would be probably a little confusing to you guys. Okay. And so then we get x is equal to the square root of 2, which would go here. Okay. And I know that seems really, really odd. So what happens is this. In square roots, we can rationalize things, which we're going to get into more in class. So the shortcut that I've told you in class is the leg is going to equal to the hypotenuse times the square root of 2 divided by 2. Okay? And again, we'll talk more about why that is in this case. Because we could do Pythagorean theorem and then it gets kind of tricky a little bit. So in this case here, 2 is going to go up here, correct? And then times the square root of 2 divided by 2. And what happens is, in this case, because the hypotenuse is even, this is important to know, these are going to cancel out and we're left with the square root of 2, which is what we got when we did Pythagorean theorem. Okay, and then since these legs are the same, this side would also equal to the square root of 2. Okay, let's try another one. This time let's make it 20. So in this case, it would be 20, the hypotenuse, times the square root of 2 divided by 2. And because the hypotenuse in this fraction is even, these two things are going to reduce or simplify and become 10 times the square root of 2. Okay, and if we did Pythagorean theorem this way, using the calculator, you would get the same answer. Okay, you would get the same answer that way. Okay, all right, now what happens if it's odd? Say the hypotenuse is 23. Okay, well, it would be 23 times the square root of 2 over 2. And if the hypotenuse is odd, we leave the answer like this. And my hint in class was, this looks really odd. And so we leave the answer like this, and that would be the other leg because they're the same. Okay, so these are the two shortcuts. I went through examples on how to use them. We talked about on this one, if the hypotenuse is even, then we have to simplify it. And then we talked about if the hypotenuse is odd, that we leave it the same. All right, so, and that's what you have to do. You have to look and say, what are we given? And then try to figure out, how to do it. So this really does not require a calculator. It just requires you to plug the number in and then either reduce the fraction or not in that case. Okay. There are some more challenging problems that involve more square root type calculations, and we'll talk more about those in class, but this is the basics on what I'm going to ask you to do for class.